Hello everyone, my name is Ravit and today I'm going to talk about classification in Python. Machine learning problem types are often categorized to supervised and unsupervised learning. In supervised learning we have labeled data and we try to infer a function or an algorithm in order to predict a target value, or actually to predict the group our sample originated from. While in unsupervised learning we have unlabeled data and we try to identify patterns or clusters to predict the target value. According to the data type, whether it is categorical or a continuous variable, we decide the learning method. So today I'm going to talk about classification. I will summarize the process of classification using the example of the iris dataset. This dataset is composed of 150 samples of iris belong to 3 species. We denote the label as lowercase y and the sample feature as capital letter X. From the dataset we can extract a training set, which we build our classifier from it. The classifier is a function mapping from an input value to its target value. Having a classifier, we can predict the label of unknown data. So, classification using Python. First of all, we need to import the general libraries. Secondly, we load the dataset, and I chose to display the dataset as a data frame object for convenience. Before applying our machine learning method, it is really important to examine our data. So first of all, we need to scan our data briefly. It is really important because sometimes we need to do some pre-processing on our data, cleaning some items. Sometimes we need to deal with missing data. And actually, just having a look at our data can provide us a first insight on the appropriate machine learning method to use. We can explore the general attributes of our data and look at the shape of our data, the number of rows and columns. We can look at the statistics of our data by the describe command and more. Additional really cool thing we can do is the multi-scatter plots, as you can see here. We can do that by the scatter matrix command. Actually, this plot produces us a scatter plot for each possible pair of features, as you can see here. And each dot actually represents a sample in our dataset. And the color represents the group our sample originated from. So we have 3 species. This is really important since from this figure we can conclude which pair of features gives us the best separation between the 3 species we have. And we can use that for our classifier. On the diagonal we can see distribution of the features. We can also do 3D scatter plot to represent 3 features. So before applying our classifier, it is really important to use the train test split command from the scikit-learn library. This command actually receives the sample feature X and the label column Y and splits it to 4 subsets of train and test. This is really important for our classifier. So I chose the KNN method, K nearest neighbors, which is really simple and popular method. It is really easy to use. This method actually memorized the data it saw before, and when classifying a new point, it looks for the K examples with the closest feature to the new data, and thus it creates the classification. So the K represent the number of neighbors, and it is really important factor since it balances between overfitting and underfitting, as I will show you later. So first of all, we need to create an instance of our classifier and to mention the number of neighbors. I chose 7 since my evaluation here showed me that this value gives me the lowest error rate for the classifier. Next, we need to fit our train set to our classifier as written here. And finally, we can look at the score of our classifier. Here we see that the score is 97%, means that our classifier is really accurate. So this is a really good model. Finally, we can create this nice figure which shows us the separation boundaries of the classifier. Each color represents the different group we have. And the dots you see here representing the data of the train set. We chose petal length and petal width as the features as I showed you before in the scatter matrix, because I saw these two features gives us really good separation between the three classes. As I showed before, it is really important to choose the right number of neighbors. Here are other choices of our neighbors, the number of neighbors. And when choosing smaller k values, our classifier became sensitive to overfitting noise, and outliers and mislabeled data, as you can see here. While choosing larger k values result in smoother boundaries of the classifier, which result in less accurate classification. So this is the code I created this figure from. Unfortunately, I don't have time to explain it, but hopefully I will do it next time. I really hope everything was clear, and thank you very much for watching.